Hey, this is a video for 4.1, Plate Tectonics. So go ahead and check out the overview and set up your guided notes. So before we can talk about plate tectonics, we really have to talk about what's happening beneath the Earth's surface. And we have a very hot core of the Earth, which consists a lot of iron and nickel. And there's also other elements within the Earth's or beneath the Earth's surface. And we have like thorium, potassium, and uranium, and they are undergoing radioactive decay. And that process generates an immense amount of heat. Well, this heat needs to escape, and it is in a liquid form because the mantle is composed of melted rock. The core is, there's a solid inner core. The core is very hot. And this heat is rising up because it's going from hot to cooler. And this is through convection currents. And convection currents is simply just the transfer of heat in a fluid from warmer to cooler areas. Convection currents can happen in a liquid, a molten rock like magma. It can also happen in the atmosphere, which we will see in future lessons. But what happens is this warm rock from deep within the mantle rises up, hits the outer area of the mantle where it's much cooler, and it separates. And it then pulls with it part of this lithosphere. And the lithosphere is basically the Earth's crust and the outermost portion of the mantle. So it's pulling with it this lithosphere, and that lithosphere is going back down into the mantle where it melts, and then this process is repeating itself. So convection currents are simply the movement of liquids from hot to cold, really. Again, it could be seen in an atmosphere, in gaseous phase, like in the Earth's atmosphere as well. Now, again, just pay attention to this example here, this diagram. We have a few things going on. We have the lithosphere is composed of the crust and the outer layer of the mantle. You can pretty much, they're not the same thing, but whenever you see lithosphere, it just means the solid portion of the Earth's surface. The asthenosphere is the outermost portion of the mantle, and you might see this term. I don't really think you have to define it on any tests. I haven't seen, but never say never. But what's happening is basically the lithosphere is being pulled by these convection currents, and then there's an area where one part of the lithosphere goes under another part, and then it brings it back into the mantle where it begins to melt, and then basically it's recycling this rock. So we'll talk about trench and ridge in the next couple of slides. But another thing I want you to pay attention to is the mantle is the part of the Earth's inside the Earth's surface that contains molten rock or magma. Now, at these boundaries where the lithosphere meets itself, if you notice here, we have part of the lithosphere is moving to the right, part of it's moving to the left. When they come together, these tectonic plates, we have what is called a convergent boundary. And convergent boundary is just a plate boundary in which two plates collide. One plate goes into the other. Now, when this happens, you can form mountains and volcanoes because what's happening is this lithosphere is being pulled down. It's melting into molten rock, and that rock needs to escape, and it usually will escape through a crack in the Earth's surface, and that's when volcanoes are formed. When you have a situation like this, you can have either oceanic or continental plates. If an oceanic plate meets with a continental plate, the oceanic plate will always go underneath the continental plate because the oceanic plates are more dense. Now, this can also lead to the formation of a tsunami, and a tsunami can happen when there is a large movement of water under the ocean surface. So, for example, if there's like an earthquake that displaces a large amount of water, this big giant wave will start flowing throughout the ocean, and that's what a tsunami is. Another thing that can happen, and this is the what you see here, it's called subduction. That's when one plate goes underneath the other plate. And this will happen only in convergent boundaries. And subduction will always occur if there's an oceanic and a continental plate. If you have two oceanic or two continental plates, one of them will go underneath the other one, but they might crumple up a little bit and also can form mountains in that sense. Another thing that you might see is you might see a lot of earthquake or seismic activity during or at these convergent boundaries, because anytime that plates come together, one of them might slip. And whenever a plate slips and releases a lot of this built up pressure, that's what an earthquake is. Whenever earthquake happens underwater, again, it can lead to a tsunami. So a divergent boundary, if you check out these arrows, a divergent boundary is a plate boundary in which the two plates are moving apart. In this case, this is happening in the ocean. So these appear to be two oceanic plates. This could be representing an ocean. Now, when this happens, this is very common in oceanic plates. And when it happens in an oceanic plate, it results in seafloor spreading. In other words, the ocean is getting larger. And in fact, this is happening in the Atlantic Ocean. The Atlantic Ocean is actually growing about the same rate that your fingernails grow. I know it's weird, but that's about what it is. About a centimeter a year. Don't quote me on that, but I think it's that. It's a really small amount. When divergent boundaries occur on a terrestrial area or on land, you will get a rift valley. So they're both going to look very similar, but basically what's happening is new crust is forming, because as this moves out, it is exposing some of this molten rock, which then cools and hardens into rock. And a transform boundary is, if you notice here, it's when it's a plate boundary in which two plates are sliding past one another. And when they slide past one another, they're generating a lot, or they're building up a lot of pressure. So this is not just an easy slide. It's not really going to be smooth like that. There's going to be jagged edges and whatnot. It's going to be rock sliding upon rock. And that's going to build up a lot of pressure. And then all of a sudden, boom, when it releases a lot of pressure, and that's an earthquake. These boundaries have a very high probability of earthquakes, and this does occur in the San Andreas Fault. A fault is just where two boundaries or two plates are meeting. The San Andreas Fault is along the coast of California, and you probably hear about a lot of earthquakes occurring in California. Well, it's because of the San Andreas Fault. And again, these plates are under a huge amount of pressure. So we have tectonic boundaries all throughout the Earth, but some of the locations that you'll see on a map is when you see around Hawaii, that has hotspot volcanoes, and I'll explain that in a minute. You're going to have a transform boundary. This is in California. You're going to have seafloor spreading in the Atlantic Ocean. Again, the ocean is moving apart, or the plates are moving apart, so the ocean's actually getting larger. You're going to have geothermal vents up here in Iceland. Iceland is very well known for its geothermal vents, for its tectonic activity. You will also have a mountain range forming. Millions of years ago, the Indian subcontinent, this part right here, basically smashed into China, and the ripple effect is the Himalayan mountains that were formed. So the Himalayan mountains are very young mountains relative to the age of the Earth, and they're also very high mountains because there hasn't been a lot of weathering to occur to basically make them not as tall. And then finally, where we have earthquakes, we had earthquake in 2011. We had a big one in Fukushima in Japan, and we'll talk about that throughout this year. But you're going to have a lot of earthquake activity in Japan. Now, where there are a lot of plate boundaries along the Pacific Ocean, and you will have either seismic activity like an earthquake, or you'll have volcanic activity. And this area is called the Ring of Fire. And the Ring of Fire, again, is where you're going to have a higher probability of earthquakes and a higher probability of volcanic activity. Now, we also have volcanoes occurring in Hawaii, but Hawaii is not technically a part of this ring of fire, even though it's in the ring of fire. The ring of fire is actually this ring shape, and these are where all the plate boundaries are found. So in Hawaii, we have what is called hotspot volcanism. And that's where you have a little thin area on the Earth's crust, or in the lithosphere, a thinner area where the plates are moving through it. And you're going to have some of this magma that is seeping up towards the surface. Kind of like if you have a little thin area in your socks, like how your toe can start peeking through that. That's what's happening in the lithosphere in these areas. So what happens is you get a little tiny volcano. And then as these plates are moving across, you're going to get another volcano. And then the plates move across and you get even another volcano. So if you notice, you're getting basically a little volcanic chain. And this is what happens in areas like Hawaii, in areas like the Galapagos, in the Canary Islands, in different areas where you have little tiny islands all next to each other, kind of seemingly almost in a line. A lot of times that is going to be hotspot volcanism. And again, a hotspot is just a thin area in the Earth's crust. What I would like you to do is respond to this check for understanding. And finally, to practice our FRQs, we would like you to describe the expansion of the Atlantic Ocean through tectonic activity. I hope that this video was informative. I thank you for your attention, and I will see you soon.